Chapter 3, Basic Principles of Classical Conditioning. Part 2, Basic Conditioning Phenomena. The acquisition phase is the first part of classical conditioning, when the conditioned response forms and is strengthened. Many factors can influence how long the acquisition phase lasts and the magnitude or strength of the conditioned response when it's over and the behavior has stabilized. Figure 3.5 from the textbook shows the results of an acquisition phase in an experiment on eye blink conditioning with human participants by Gerwig et al. 2010. In the experiment, a brief tone, the conditioned stimulus, was followed by an air puff, the unconditioned stimulus, directed at the participant's eye. Each participant experienced this 100 times per day for 3 days. This graph shows blocks of 10 trials along the x-axis, with the vertical phase change lines that are highlighted orange indicating different testing days. The y-axis shows percent CRs, or conditioned responses, that is, how often the participant blinked in response to the tone before they experienced the air puff. This is the dependent variable in this experiment. Each data point represents percent conditioned response for a block of 10 trials. For example, if a participant blinked in response to the tone prior to the air puff occurring on 4 out of 10 trials, the percent CR for that block for that participant would be 40%. Now, the conditioned response either happens or it doesn't, which means that in a block of 10 trials, percent CR must be a number that's divisible by 10. There's no such thing as a conditioned response on half of a trial. You've probably noticed that most of the data points look like they're between those even divisible by 10 values. Do you know why that is? Both series, the filled and the open circles, show the average percent CR for multiple participants. So, for example, if at the beginning of day 2, the tone elicited a conditioned response on 3 out of 10 trials for 5 participants and on 4 out of 10 trials for another 5 participants, that data point would appear at 45%. Okay, let's move back to acquisition. For the normal or neurologically intact adults in this study, the percentage of trials with a conditioned response gradually increased until it leveled off at about 55% pretty early in day 2. This value, the maximum level of conditioned responding that is gradually approached as conditioning proceeds, is the asymptote. Now, like I said before, a number of factors can influence the length of the acquisition phase, the asymptotic level of the conditioned response, or both. Figure 3.5 shows one neurophysiological difference. It provides evidence that the cerebellum plays an important role in the neural mechanisms that control eye blink conditioning. Adults with cerebellar damage showed weaker levels of conditioned responding, which reached an asymptote of about 30% for that group, than adults who did not have cerebellar damage. Other factors that can influence the acquisition phase and the magnitude of the asymptotic response include the intensity of the unconditioned stimulus and the intensity of the conditioned stimulus. In both cases, acquisition tends to be faster with stronger stimuli. So to recap, during the acquisition phase of Gerwig and colleagues' experiment, and figure 3.5, the conditioned stimulus, that tone, was paired with the unconditioned stimulus, the puff of air, meaning that the puff of air reliably followed the tone. Participants responded to the unconditioned stimulus by blinking. Now, that was a reflexive response. They didn't need to learn to do it. At first, the tone didn't elicit any particular response at all, but with the repetition of the tone plus air puff pairing, participants would blink when they heard the tone before they experienced the puff of air. Now, eventually, at asymptote, the tone reliably elicited a blink before the air puff, 30 to 55% of the time, approximately, depending on which group you're talking about. Now recall that habituation, which we talked about in Chapter 2, goes away with the passage of time. That's not the case with classically conditioned responses typically. Once a conditioned response has been established, it takes more than the passage of time and the absence of the conditioned and unconditioned stimuli to disrupt the response. But of course, it can be done. This graph shows something like what might have happened to the conditioned response in Gerwig and colleagues' experiment if, on day 2, experimenters had played the tone but never presented the puff of air. At first, participants might be just as likely to blink when they heard the tone as they had been the day before. But as the unconditioned stimulus that the blink was in anticipation of didn't occur, the conditioned response would get weaker and would occur less often and eventually disappear. That is extinction. Now, it might look like we've undone the effects of conditioning, but that's actually not the case. One way that we can tell that conditioning hasn't been erased or unlearned is by continuing with those extinction trials, that is, playing the tone without the puff on subsequent days. If extinction had erased initial learning, once it disappeared, we should expect that the response would stay disappeared. In fact, researchers typically see some reoccurrence of the conditioned response, like this. It's weaker and it disappears faster with each subsequent day, but it happens, and it's called spontaneous recovery. There are a few theories that propose explanations for spontaneous recovery. For example, in the 1940s, Konorsky proposed inhibition theory. So the thinking goes that the formation of an association between the conditioned stimulus and the unconditioned stimulus is excitatory. When the conditioned stimulus, once this is established, is presented without the unconditioned stimulus in those extinction trials, that's a separate and thought to be inhibitory process. According to inhibition theory, the strength of the conditioned response is a function of a combination of the excitation from the prior association and the inhibition from extinction. The changes illustrated by spontaneous recovery, then, are driven by strengthening of inhibition with experience, that's the repeated extinction trials, and weakening of inhibition over time in the absence of extinction trials. Other explanations involve changes in attention due to a degradation of the salience of the conditioned stimulus and changes in the clarity or ambiguity of the conditioned stimulus as a predictive signal. 3 phenomena provide evidence that extinction does not erase or undo prior conditioning. The first is spontaneous recovery, like we discussed. The second is disinhibition. Once a conditioned response is extinguished, if you present a novel stimulus, that is neither the conditioned stimulus nor the unconditioned stimulus, after that, present the conditioned stimulus again, and what often happens is you get a small conditioned response. Now, much like spontaneous recovery, there's no theoretical consensus as to why this occurs, but it couldn't happen if conditioning had been fully undone by extinction. Similarly, suppose you establish and then fully extinguish a conditioned response, and you're sure you've got no more spontaneous recovery. And then you start presenting the conditioned stimulus and the unconditioned stimulus together again. You get a second acquisition phase that typically is much shorter than the first. If conditioning had been undone, then that second acquisition phase should be the same as the first one. So this rapid reacquisition is additional evidence that the initial conditioning was not erased. So far, we've focused on what happens when the presence of a conditioned stimulus predicts the presence of an unconditioned stimulus. A conditioned response is established. Of course, when the presence of a conditioned stimulus predicts the absence of an unconditioned stimulus, you do get an effect, but it's a weakening rather than a strengthening of a conditioned response. For example, suppose you really like coffee. Before you even drink it, you might have certain reflexive reactions to the smell of coffee, such as salivation. If you have a favorite coffee shop that you frequent, you might have a similar conditioned response just to seeing the shop. However, when the presence of a closed sign signals that there's no coffee to be had, your conditioned response is probably at least a little bit smaller. One of the reasons that classical conditioning is so useful is that conditioned associations for similar stimuli interact. Stimulus generalization is the transfer of a learned response from one stimulus to other related stimuli. For example, poison ivy leaves do not all look identical, but once you've learned to avoid one, usually you get pretty good at avoiding them all. If you're lost in the woods, it would be very inconvenient to have to learn not to touch poison ivy leaves from scratch with every single leaf. The opposite of generalization is discrimination. Stimulus discrimination is learning to respond to one stimulus but not to another similar stimulus. This is essential for responding appropriately to specific stimuli. For example, these berries look very similar, but one of them is edible and the other is poisonous. Do you know which is which?